working out a single sample confidence interval for the population variance. We have a normally distributed population where the population variance is unknown. So we take a random sample of size n, we work out the sample variance s squared, so this value is either given, or perhaps we can make use of this formula. This formula is in the AQA formula book on page 12. Or you can enter your data into the calculator, and then the calculator will give you the sample standard deviation, option 4. And because we're looking for the sample variance, you would square that value. So for example, if I select option 4 for the data I've entered, that's the standard deviation. Squaring that, here is the value of s squared. Once we've calculated the sample variance, we can use this value to estimate the population variance using an interval with a given probability. For example, a 90% confidence interval. And this is the formula that will give the confidence interval. So we have the population variance here. This is what we're trying to estimate using this interval. We have the sample variance, s squared. N is our sample size, and we make use of the chi-squared distribution, and we need two values from the chi-squared distribution, the lower tail value and the upper tail value. So let's have a look at the chi-squared distribution. Its origins are in the normal distribution, and we can see we have positive values here and negative values on this side. If we take this distribution and square it, we get the chi-squared distribution, and all of the values along here are positive because we've squared the normal distribution, so no more negative values. In the formula, we have a lower value and an upper value. So here's a sketch of the chi-square distribution. Here's the lower value and the upper value. We will look up these two values from the tables, the chi-squared tables. So here's a table with P probability values along the top. You've got your lower tail values on this side, and the upper tail values on the right hand side. And the number of degrees of freedom along here. Degrees of freedom is n minus 1. So for 5 degrees of freedom, we're in this row. So for a 90% confidence interval, so 90 goes in the center, 5% in each tail. For the lower chi-squared value, the cumulative probability to the left of this line is 5%, so we look up 0.05, 5 degrees of freedom, 1.145. And then likewise for the upper chi-squared value, the cumulative probability to the left of this line is 95%. We look up 0.95, 5 degrees of freedom, and here's the value, 11.070. And these two values then feed into the formula. Example 1, n is 12, s squared is given, 23.45. The population is normally distributed. This whole calculation would be invalid if this was not true. So 95% confidence interval, and then Here's the calculation. We have 11 degrees of freedom. The sample size was 12, so 12 minus 1, n minus 1 is 11. And these values come from the chi-squared tables, looking up 2.5% and 97.5%. We've got these two values, the lower value and the chi-squared upper value. They all feed into our formula. Remember, the large value, the upper value, goes on the left, and the lower value, the small value, goes on the right hand side of the formula. So we have our 95% confidence interval for the population variance. If we want the confidence interval for the standard deviation, we just simply square root. So square root this value, square root the variance, square root this value here. But you always work out the confidence interval for the variance first, and then square root to get the standard deviation in that order. Example 2. We're given a standard deviation here of 3 centimeters, and we need to just check if this value falls within the confidence interval that we're going to calculate using this random sample. The value of s squared, the variance for the random sample, is not given. So we need to put this data into the calculator and get the value from there. Option 4, and this is the value of s, the sample standard deviation. We're looking for s squared, square the value, 30.23. So we've got the s squared value, sample size is 10, n is 10, so there are 10 minus 1, 9 degrees of freedom. We're looking for a 90% confidence interval. Once we've calculated it, we're hoping that this 3 centimeters lies within the interval. If it doesn't, then the machine is not working correctly. So looking up 5% and 95% from the chi-squared tables, in the calculation we put the upper value on the left hand side and the lower value on the right hand side. So we have our confidence interval for the variance. We're testing a standard deviation in this case, so we need to square root. And 3, this value, is lower than the lower limit of the confidence interval, so the machine is working incorrectly. Example 3, our sample size is 15. The population is normally distributed, so that condition is met. And using this summarized data, we can use this formula to work out s squared. And we're dividing by n minus 1. N is 15, so we're dividing by 14 here. It's a 98% confidence interval, so we need to look up 1% and 99% from the tables. So we have the lower value and the upper value. They feed into the formula, the upper value, the lower value, and we have our 98% confidence interval for the population variance. So the true population variance is a single value, and there's a 98% chance it's in this interval. So there's a 2% chance it's not in this interval. When labeling the sketch make sure these probabilities add up to 100%.